So on the next page, we have a couple more exponential equations because the variable's in the exponent. You'll see on this one, we're gonna have to actually use a distributive property, and we'll see why in a second. So I have a 216 and a 36, both powers of 6. 216 is 6 cubed. Because I have addition in my exponent, I do need to use the distributive property when I get to that step. On the other side, 36 is 6 squared. Right, and I'm just rewriting those variables that were already there. So then I cancel my 6's, I'm going to distribute here, and I get 3x plus 6 equals 2x. Move the 3x over. So the x is going to equal a -6 if I divide it by -1. And the next one, I see a 125 and a 1 over 25, both powers of 5. So here I have a 5 to the third. And here I have a 5 to the -2. Cancel my 5's, and I get 3x equals -8 plus 2x. Move over the 2x, and I get x equals a -8. So in the next section, we're going to have mixed problems. Some are exponential equations, some are equations with exponents, and we're going to have to decide which method we're going to use. So looking at letter A, I'm just going to start out using SADMAP. I haven't even gotten to a point where I can work with the exponents, so I'm moving over the 4. Somewhat hidden, there is some multiplication to get rid of because the negative sign means we're multiplying by -1, so I'm going to divide there. So this is an equation with an exponent because I have a 5 in the exponent. Since it's an integer exponent, I could just think about using the 5th root, but I'm going to use the method we've used. We're going to use the 1/5 power, which is also the 5th root. So the 5th root of 32 is 2. Looking at the next one, now we have an exponential equation because we have an x in the exponent. So 9 is 3 squared. And 27 is 3 to the third. And then I can cancel the bases, and I have 4x plus 2 equals 3. Move the 2 over, and divide by 4, and I get 1/4. Sometimes with these exponential equations, we will get something that says to the nearest 10th or something like that, and that's just because when we get to taking the root, we're not going to have a rational number. So, for example, on this one, we're going to start out with our reverse order of operations. So 42 minus 8 is 34. And then we divide by 6. So when I get to this point, I see I have an equation with exponents, so I need to use the reciprocal power to cancel out that exponent. So this is not something, I can't really take the square root of 34 or 6 and get a nice number. So I'm just going to type that in my calculator. It says nearest 10th, and that should come out to 13.5. The next one, move over the 32, and you should be doing all these on your own first. We're kind of at that point. So if you haven't been, make sure you're pausing and doing those. So exponential equation, common base, 32 is 2 to the 5th. Cancel them out. Move over the 9. And then divide by 2. So we get x equals 7 for that one. Letter E is kind of a weird situation. Usually we're trying to go to smaller numbers to make bases. But here, if I have a 1 as my base on one side, we can write that as anything to the 0. So since I can't really make a 15 into a 1, I can make a 1 into 15 to the 0. So that's kind of a different situation that we want to notice if we see 1 as one of our bases. And then from there we can cancel out the 15s. I'm going to move over the 6 and divide by 3. And I get -2 for that one. So here's another one where we need to go to the nearest tenth. So what I'm going to do first, because we have parentheses, so I actually need to get rid of the exponent first, we're going to use the negative 1/4 power. That will cancel the exponent. So if I type 30 to the negative 1/4 in my calculator, I get approximately 0.43. So sometimes if I know I need to go to the nearest tenth, I'll just write down a couple extra decimals as I move on. It does not matter what you write as long as we keep this value in the calculator and keep highlighting as we use it. So next I'll add 4 to both sides and then divide by 3. And keeping that whole decimal in my calculator to the nearest tenth, this comes out to 0.1, which does not sound right. So I'm going to grab a calculator quick. Sorry, this will make the video a little longer. So I have 30 to the negative 1/4, and that is 0.43. And then when I divide it by 3, I do get, oh, you know what? This is why it's wrong. I wrote this down wrong. 4 on my calculator, I forgot to move it to 4. So this is 4.43 divided by 3 because I moved the 4 over. And that's the number. So this is 1.5 is what this one should come out to. Sorry about that. So we're actually going to do the next page on this video as well, just because there's only 2 more questions. So exercise 4 is just a little bit of a mix. We have one of these types of equations, but it's starting as a system. So if we're solving a system of equations, they're both y equals, so we can use substitution and set them equal to each other. These are exponential equations, or an exponential equation where I can make the bases the same. So 8 is 2 to the 3rd. And 24 is 2 to the 2nd, or 4 is 2 to the 2nd. Bases cancel, and on this side I have 3x minus 3, and this side I have 4x minus 6. So I'm going to move the 3x over, subtract it, and get an x on this side. I'm going to move the 6 over and add it and get a 3 on this side. We want to be careful that we don't stop there because we are solving a system, so we have to plug that x value in to get the y value. I'll just choose the first equation. So 8 to the 3 minus 1, 8 squared is 64. So my answer is 3, 64. If I graphed those, I would see that intersection point. So here is a little bit of a step up because we have an extra variable in this equation. It says, at what x coordinate will the graph y equals 25 to the x minus a intersect the graph y equals 1 over 25 to the 3x plus 1. So again, we're going to use substitution and set these equations equal to each other. And again, I have exponential equations, so the base is the same. 25 is 5 squared. And 125, or 1 over 125 is 5 to the negative 3. So I can cancel my bases, and I get 2x minus 2a equals negative 9x minus 3. And I'm going to look back. And it looks like each of these equations is solved for x. So I'm basically getting the x's to one side and moving everything else to the other side. So I'll add 9x this way and get 11x. I'm going to add 2a this way and get 2a minus 3. And then lastly, I need to divide by 11. And I do get x equals 2a minus 3 over 11.